Hi guys, in this video we'll be discussing the daily Leetcode challenge for 5th of January. The problem's name is minimum number of arrows to burst the balloons, and the problem states that there are some spherical balloons taped onto a flat wall that represent the xy plane. The balloons are represented by 2D integer array points where points I is equal to x start and x end. That denotes a balloon whose horizontal diameter stretches between x start and x end. You do not know the exact y coordinates of the balloons. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x start is less than equal to x and is less than equal to x end. So our x should be greater than or equal to x start and should be less than or equal to x end. Only then it would burst this particular balloon. Also, there is no limit to the number of arrows that can be shot. A short arrow keeps traveling up indefinitely, bursting any balloon in its path. We have to return, given the array points, return the minimum number of arrows that can be shot to burst all the balloons. Now let's try to understand what the question says. So they have given us some examples as well. So the example they have given us is 10, 16. Then we have 2, 8, 1, 6 and 7, 12. So let's get started with the question. So this is the example they have given up. So firstly, let's try to understand what the question was saying. So they say that we have a 2D plane. So as you might know, this is the x-axis, this is the y-axis, and then you have some balloons at different different heights and different lengths. So they have different x-axis and they have different coordinates for x, they have different coordinates for y. So now we have to fire arrows from the bottom. So we'll be firing this arrow, we'll find another arrow over here, we can find another arrow over here, we can fire one here, fire one here, fire one here. So in this case, let's say we shot 6 arrows and 6 arrows were able to kill all the balloons or burst all the balloons. So this also got bursted, this also got bursted, and we have to return the minimum number of arrows. Now when would a single arrow burst more than 2 balloons? So a single arrow would be able to burst more than 2 balloons when arrow is shot and it is between the x start and x end of more than one balloon. So this is the x start of, let's say, the 0th balloon, this is the x end of the 0th balloon, this is the x end, x start. So this is the x start of the first balloon, this is the x end of the first balloon. So in this case, it would burst these 2 balloons. Now we need to minimize the number of arrows. So if we want to minimize the number of arrows, technically we want to burst as many balloons as possible with minimum number of arrows, right? So how would we do that? Now you can say that if we think about it greedily, so let's say there are several balloons. Let me draw balloons with a different color. So okay, so we have a balloon over here. Let's say we have a balloon over here, then there's one over here, then over here. Let's say something of this sorts. Now you can say greedily that this is the starting point. So the first arrow needs to be shot before the ending of the first balloon if I need to burst the first balloon, right? And since I have to burst all the balloons, so I don't have an option of leaving out any balloon. So I can say I'll have to fire the first arrow at most by this time. I can't wait after this, right? So I have to fire it by this point. When I fire this particular arrow, so both of these balloons get busted. After that, what I can say is that this balloon was already busted, so I can leave this, but then this is remaining, right? So I also have to burst this arrow, and the last time at which I can burst this balloon is this particular point. So I'll have to fire my arrow over here itself. So when I fire an arrow over here, so it bursts these 2 balloons, then I'll traverse again. So I'll see, okay, this balloon is over here, but it's already bursted because its x start was less than the x, or less than equal to, you can say. So this was already bursted. Similarly, this balloon was already bursted, so I can say I need 2 arrows in total. Now this intuition was really simple, but how do we code it? So when we're trying to code it, what we can say is that I want to sort my balloons, but in what fashion would we sort it? Should we sort it based on the starting points or the ending points? Starting points or the ending points. Now let's try to take an example. Now let's say we have a big balloon over here and a smaller balloon over here. Now if we sort it, because there's no limit to the diameter of a balloon, so it is possible that this balloon, there's a balloon over here and there's a balloon over here, or let's say there's a balloon over here. So this is a big balloon, and on top of it there was a small balloon over here. So if we sort it on the basis of the starting points, so this would be the first balloon I'll consider, and then I'll say I have to travel it till the end, and then I'll fire a arrow over here, right? As soon as I fire an arrow over here, this gets bursted, but this is still present. So for this I'll have to fire another arrow. So number of arrows required would be 2. However, is it optimal? Definitely not. I could have simply shot an arrow over here, and that arrow would have been able to burst this as well as this balloon. So my optimal number of arrows was 1, but I got a wrong answer. So how do we treat that? So what I can say is that I actually want to sort based on the endpoints. Now let's say had I sort based on the endpoints, so I would have known that this is the balloon which has endpoint first. So I would have checked for this only, and I would have shot my arrow over here. As soon as I would have shot my arrow over here, this arrow would have been able to burst both the balloons, and I would have gotten my optimal answer. So one thing is very clear, that I simply need to sort it. So sort based on the endpoints, and that's what I'm gonna do. Once I'm able to sort it based on the endpoints, then I'll simply iterate over the over the array of balloons, and I'll keep a counter to the last balloon I've bursted. So I'll see that okay, the last balloon I've bursted should always be recorded. So for every balloon I'll check if its start is greater than or equal to, if its start is less than or equal to the previous arrow shot. So I also have stored the coordinates of the arrow shot. Then this balloon would already have been bursted, right? So I can continue. Else I'll need to shoot this particular balloon down. So in that case I'll increase the number of count or the number of arrows, and I'll also update the last shot coordinates or the last arrow shot coordinates to the endpoint of this particular balloon, B1, let's say. That's it. At the end I'll return the number of arrows that is represented over here by count. It's that easy. So let's try to code this up. Okay, so they have given us the points. So let's say initially I'll be using a long over here. I'll soon explain the reason why. And the number of arrows is, let's say ARR arrows is 0 at the start. I've not shot any arrows, and the previous location of the arrow that I have shot is, let's say, -1 into 10 to power 9. So I'm just giving it a dummy value because I've not shot any arrow as of now. So I'm giving it a really negative value so that it works. Okay, so for all the points that are present in these points, what I need to do is that start is equal to 0.0 and the end is equal to 0.0 or 0.1. Then I can say if start is less than equal to the previous lock, then definitely my balloon is already bursted, so I can continue. Else I'll have to increase the number of arrows, and the previous location of the arrow shot would now be updated, and it would be updated to E. At the end I'll simply return arrows. Let's try this out. Let's see if this works. Okay, I'm getting an error. Why is it so? So it's 2 8. What am I messing up over here? Okay, I haven't sorted it actually. I forgot the major step itself. So let's sort it first. Sort points dot begin, points end. Then I can use an anonymous function. So I can say vector int a and vector int b. Now the way I want to sort is that if the endpoints are different, so return if a1, that's the endpoint for a, is not equal to endpoint of b, so return me the smaller one. If they are equal, then return me whosoever has a minimum starting point. I hope that makes sense. So let's try that. Cool, this works. Let's try submitting it. Cool, you can see this particular solution works. And let's talk about our, so this you really don't need to see this particular number, because what happens is that even if you compile the same code twice, it will give it can give you a different value over here. So if I try to submit it again, okay, so this time it's beating 53%. Last time it was giving it beating 18%. So this doesn't matter. What matters is the complexity of your code. So the complexity of a code is n log n, because we are using the sort function once over here. After that, we are using only order of n operations. So the final complexity turns out to be order of n log n. So yeah, that's the code that's required for it. I have given a detailed explanation as well, but if you still have any doubts, let me know. Thanks a lot, guys.